Hello everyone and welcome to Lesson 6 of the Algebra 2 summer course. Today we're going to be talking about domain and range. In my opinion, domain and range is one of the hardest things that I find students take to learn, and usually they forget it by the time, basically so much as a month after they take the quiz. But I will say this, it is an important topic. Not the most important, I'll admit it, but it is an important topic, and along with domain and range, we are going to be talking about inequalities and also interval notation, which is a way of representing a solution set. And I'll explain what I mean by that later on today. But first, we have here domain. Domain is all the possible x values that you can plug into a function. The domain for most functions is all real numbers. And if you want to write that in interval notation, then you would say negative infinity to positive infinity. So when I say all real numbers, that's just a technical math term. All real numbers basically means any number you can possibly think of. This includes numbers that are weird, such as pi. It includes square roots, such as the square root of 2. The only thing that it does not include is imaginary numbers, which we have not talked about this summer, but you probably will at some point in Algebra 2. So basically it includes everything except imaginary numbers, which you probably don't even know what those are yet, so it doesn't matter. Now, I said the domain for most functions is all real numbers, and the reason for why that's true, you don't have to write this down, you can just look. It's because if I were to draw basically any graph, let me just make up a graph like this. Okay, there's a beautiful graph right there. There's no value for x that's going to break the function. In other words, let's just say that this is the function y equals x cubed minus x. It doesn't matter what it is exactly, but the point is this. No matter what value for x you plug in, there's no value for x that's going to break the function, cause an error in your calculator. You will get a result for every possible number you plug in. And so for that reason, we would say the domain is negative infinity to positive infinity. And look at the graph. There's every x value on the graph is accounted for, and the arrows mean it goes on forever. So you're definitely going to account for basically every possible x value. Okay, so back here. Basically, there's only two things you have to worry about where the domain does not exist. Number one is a 0 in the denominator. A 0 in the denominator will either end up being a vertical asymptote, which maybe you don't know what that is. It doesn't really matter right now. It could also be a hole in the graph. So we need to find out if there's a 0 in the denominator. And number two, we have to be on the lookout for negative square roots. You cannot have negative square roots. An example of this, you cannot have the square root of negative 2. Because if you plug this in your calculator, it's going to throw an error back at you. Any questions on those first two things? Now let's talk about interval notation. Interval notation is just a way of drawing inequalities on a number line. And so for instance, if I want to say x is greater than or equal to 3, what I'm going to do is I'm going to put a closed circle at 3, and then I'll draw it in a different color. I need to label to the right of 3 because greater than means to the right. I'll even make a note of that real quick. Greater than or greater than or equal to means you want to go right. And if you see less than or equal to, that means you want to cover the left. Now keep in mind, this system only works if x is first or on the left side. In other words, if I had 3 is less than or equal to x, you would have to flip it around. X is greater than or equal to 3, okay? So we want the x to go first in order for this system to work consistently. So there's my inequality, but the bigger question is how do I represent this in interval notation? Basically, interval notation just looks like this. It's the low number, comma, the high number. And in this case, the low number is 3. And the high number, you may not see it, it's infinity because it keeps going on forever. So what I'm going to do here is I'm going to put 3 comma infinity, And then I put parentheses here just as an example, but it's not always parentheses. Parentheses, let me say it here, parentheses, which look like this, that is for less than or greater than. In other words, not the equal to case. You then use a square bracket. You want to use square brackets, which look like this. And you do that for greater than or equal to or less than or equal to. The key difference here is the equal to sign. So in this case, do we want to include the 3? Yes, because it's greater than or equal to. So square bracket around the 3. Do we want to include the infinity? The answer is no, not because we don't want to, but because it's impossible to contain infinity. It's infinite. That's kind of one of the properties of infinity. So in other words, another note for you, infinity always gets parentheses, not square brackets. Infinity will always get parentheses. So here is our answer, square bracket 3, comma, infinity, parenthesis. And I will be strict with the square brackets and the parentheses today. But are there any questions on this first page? Okay, now we're just going to do a couple more. For the next one, -1 less than or equal to x less than 5, on the number line, write the expression in interval notation. So here's what I'm going to say. First, with -1, you see it's less than or equal to, so I'll put a closed circle here. And then the 5 gets an open circle, don't fill it in, and that's because it's less than, not less than or equal to. And then see how x is in the middle of these two? That means the correct region is in the middle of my 2 points here. And then how would I write that in interval notation? Well, remember, it's the low number, comma, the high number. -1, comma, 5. And -1 will get closed brackets or parentheses. Which one? It's going to be closed brackets, square brackets, because you want to include the -1. And then 5 gets parentheses because it only has the less than sign, not less than or equal to. So there we go. There's our answer for that one. Okay, now the next one. Draw x is less than 1 and x is greater than 4 on the number line. Write the expression in interval notation. So this one, you see it's going to be double open circle at 1, open circle at 4. And if I want to say x is less than 1, that's this region to the left. And if I want to say x is greater than 4, that's this region to the right. Which means I include everything but the middle this time. How am I going to represent this in interval notation? The answer is, you see how there's 2 regions here? Well, that means you need 2 sets of numbers, basically. And I'm also going to put negative infinity and positive infinity on this number line because I'm going to need it for this interval notation. So the first low number is negative infinity. And that, of course, gets parentheses because infinity always gets parentheses. Comma 1. That's the first high number. In other words, I got the first red region, negative infinity to 1. That is parentheses on the 1 because it's less than, not equal to. And now I need a way to say the other one. If you want to join 2 intervals together, kind of like the word and in English for compound sentences, you want to use the union symbol, which just looks like a capital U. It's called the union symbol. And now the second region, it's going to be 4, comma, infinity. Why? Because 4 is the low number, infinity is the high number, and everything gets parentheses because there's no equal to sign. And this is our answer. And yes, there are 2 regions. Theoretically, you can have 3, 4, 5, 6 regions, all combined with the union symbol in between. And that's how we do interval notation there. Any questions? Okay. So that's enough for interval notation. Now we know how to write it. We can now talk about domain, because we're going to write our answers for domain in interval notation. You can write it in inequality form as well, technically, but interval notation is just going to be a good step for the long run. And that's because a lot of your teachers will in the future ask you for interval notation. Okay, so case 1, the 0 in the denominator. How do we find that? All you need to do is set your denominator equal to 0. And so what that means is, if I have an example of, let's say, 1 over x plus 5, then I need to set my denominator equal to 0. X plus 5 equals 0. You end up getting x equals negative 5. But remember, we're saying x cannot be negative 5 because we can't have 0 in the denominator. So basically, the domain would be every number except for negative 5. That's how you'd write that in English. Now, case 2, negative square roots. So for this example, let me just start off with it. If you have, let's say, 2x minus 4. Remember, x cannot be negative. Think of some numbers you can plug in here. Like, for instance, if I plug in 0, then I get 2 times 0 minus 4. That's the square root of negative 4. That would be no good. So clearly 0 doesn't work. You can try 1, you can try 2. You can try like all the x values you want. And eventually you'll solve for it and you'll get x equals 2 is the point where it switches from working to not working, is at x equals 2. That's where it turns into a negative square root. But my advice to you would be to do something smarter. And the smarter thing to do, instead of just plugging in random points, is to say 2x minus 4, the thing under your square root, must be greater than or equal to 0. There's your strategy. Thing under the square root greater than or equal to 0, and yes, always greater than. Can't be less than, because that would be not good. So now if you want to solve this, you just add 4 to both sides. 2x is greater than or equal to 4, and then you divide by 2. X is greater than or equal to 2. And again, all these answers I've said so far are in inequality form. We are going to be doing the same thing in the questions below, but we're going to be converting them to interval notation. Okay, so any questions on that? Oh, one more thing I want to mention with inequalities. If you ever divide by a negative number, like let's just say you have this. If you divide by a negative number, you flip the sign of, I should say the direction of the inequality. So before it was less than, you divided by a negative, you switch the direction. That's when you switch directions. Okay, so now let's look at some examples. Number 1, here's the function y equals 2x squared minus 3x plus 11. I want to find the domain, and I also want to write the answer in interval notation. So can someone tell me what the domain problems are here? What values of x do not work? The answer is there are no values for x that will not work. In other words, every value for x works. And you may be wondering why is that? Well, because remember, there's only 2 things we have to worry about. There's a 0 in the denominator, and you notice there is no denominator because it's just a normal expression. There's no fraction. And then the second thing you have to look out for is a negative square root. Well, there's no square roots either. So literally because of those 2 reasons, the domain is all real numbers. Every x value works. But it says to write the answer in interval notation. So instead of saying all real numbers, I'm going to write negative infinity to positive infinity. If you want to know what that looks like on a number line, it looks like this. There's negative infinity, there's positive infinity, and my red region, the region that works, is literally the entire number line. That's what it looks like. Any questions on that first one? Okay. So next, number 2. For number 2, we have y equals x plus 4 divided by x minus 6. What's the domain problem here? Well, obviously, it's the denominator. You cannot equal 0 in the denominator. So the best way to solve for that is to say x minus 6 equals 0. Add 6 to both sides, x equals 6. But remember what we said earlier. It's actually x cannot be 6 because your denominator cannot be 0. But how are we going to represent that in interval notation? Let's think about it. On a number line, here's 6. We know it's an open circle because it's not just because it's, greater than or less than, but because you don't want to include 6. So 6 gets an open circle. That's what the open circle means, do not include. And so to the right, you're good. To the left, you're good. But every point except 6 will work. And remember, you're surrounded by negative infinity and positive infinity. So in other words, if I want to write my answer in interval notation, first of all, I know I'm going to need the union symbol because I have 2 regions here, one on the left, one on the right. So the first region is negative infinity to 6. Infinity always gets parentheses. The 6 gets parentheses this time because we do not include 6. It's an open circle. And like I said before, union with the other red region. The other red region, the low point is 6, the high point is infinity. And once again, both of those are getting parentheses for the same reason as before. And there is our domain. In other words, it would be a whole lot easier if we just wrote x does not equal 6. It's not the point what's easier, but you're right. That's clearly easier than the interval notation. The point is, do you know how to do both? Do you know how to do inequality form, which you probably already know how to do, and do you know how to do interval notation, which is probably what you're less familiar with? I'm going to encourage you today to use interval form because it's not so easy or intuitive and you need to practice it. Any questions on number 2? Okay, great. Here's number 3. F of x equals 3 divided by x squared minus 5x minus 6. What are we going to do for this one? So first I would say the problem is your denominator cannot be 0, right? So we're going to say x squared minus 5x minus 6 equals 0. And now we need to solve for x. How do I solve for x here? Well, remember, whenever you have an x squared, you can factor it. We can factor this. The factors of 6, it's either going to be 1 and 6 or 3 and 2. Since that negative sign right there means that 1's negative, 1's positive, and you need to add or subtract them to negative 5, I think 1 and 6 are going to make the most sense here. In other words, it's x minus 6 times x plus 1. I'm assuming factoring is something you're good at by now. If not, you can go back to a previous lesson this summer where we talk about factoring more in detail, but seriously, it's a very important skill to have for this reason. And we're going to get 2 solutions here. You get x equals 6 and negative 1. And remember, that does not equal 6 or negative 1. So now this one, when I put on my number line, it's going to look like this. Here's negative 1, here's 6. Both of them have open circles because you do not include them. And then this time my solution space looks like I have 3 regions. Okay? And I'll again put negative infinity and positive infinity to remind myself what goes on here for interval form. So the first region on the left, it's low number negative infinity, next number negative 1. Again, both of those get parentheses. You don't include infinity, you don't include negative 1 because of the open circle. Then we would say union. The next region is negative 1 to 6, so negative 1 comma 6. Once again, both of those get parentheses. And then the last one, union with 6 comma infinity, that's the last region. All those get parentheses again, and there's our answer. And you may be wondering, does the order matter? Like, can I go from right to left, or do I have to go from left to right? You have to go from left to right. You have to go from smallest to largest. That is one of the rules of interval form. Any questions on that one? Okay, next. Number 4, we have f of x equals the square root of x plus 2. We have that square root one. So what do I do for square roots again? I need to say x plus 2 is greater than or equal to 0. And so then I would say x is greater than or equal to negative 2. So then that's your answer in inequality form, but we want to write our answer in interval form. So again, I go to my number line and put a negative 2 there. It's a closed circle this time because I include negative 2. And since it's greater than, I want to include the right side like this. So it looks like it's going to be negative 2 to infinity. Just like that. Can anyone spot the error in what I just wrote? The error is the fact that I said greater than or equal to. That means this is not parentheses, it's a square bracket because we want to include it. Okay, so with that being said, there's my answer. Why don't you try number 5 on your own? If you're watching the recording, just pause the video. I'll give you a minute to solve this. You can now unpause the video. I'm going to show you the solution. So the first thing I want to do is I want to say 5 minus 2x is greater than or equal to 0. Okay, next, there's a couple things you can do. You can either move x to the other side or you can subtract 5. I'll subtract 5 because I like to keep x on the left. So negative 2x is greater than or equal to negative 5. Looks like we're about to have a fraction here. And that's okay. Fractions don't really matter. They don't scare me. Divide both sides by -2. And we remember, when we divide by a negative number, you switch the direction of the sign. So now it's less than or equal to. And -5 divided by -2 is just 5/2. So now on my number line, I only have 5/2. It's a closed circle because I include it. It's less than or equal to. And less than means the left side. So it looks like this time, I'm going from -infinity to 5/2. And that's what I'm going to write. -infinity, comma 5/2. And the 5/2 is the only one that gets the square bracket. Hopefully you got that, but are there any questions on number 5? Okay then, moving on. Number 6 is a hard one. I'm not going to ask you to do that yourself. I'm going to help us through this one. So, first of all, you notice there's 3 problems here. Let me outline them all. First of all, you've got a square root in the numerator. Second of all, you've got a square root in the denominator. And third of all, your denominator cannot be 0. That's 3 things I have to worry about. Let's just focus on the numerator at first. That's the easy one. So first, I need to say, not the square root, just the thing inside the square root. 2x plus 2 must be greater than or equal to 0. So then that means subtract 2 from both sides. 2x is greater than or equal to -2. And then divide by 2. X is greater than or equal to -1. Okay, we'll worry about that for interval notation at the very end when I do my number line with all this stuff. But there's my first solution, you could say. Now for that square root of 9 minus x in the denominator. I don't want you to say, let me tell you what I don't want you to say. I don't want you to say 9 minus x is greater than or equal to 0 because of the square root, even though that's what we normally do. And then I also don't want you to say 9 minus x equals 0 to account for the the 0 in the denominator. In other words, if you were to do these individually, these 2 problems, you would get, whatever you'd get. But here, I'm going to combine them into a single step. And how do I do that? Basically, I'm going to write a note down. The note is, if you have a square root in the denominator, then use greater than instead of greater than or equal to. And the reason why is because equal to means it can be 0. But this cannot be 0 because we're in the denominator. So in other words, all I got to say is 9 minus x is greater than 0, and that is how I account for the square root in a denominator. And then I just solve like normal. Subtract 9 from both sides, -x less than -9, and then you divide by -1. So it looks like x is actually less than +9. And again, I switched the direction because of the dividing by a negative. Okay, so hopefully you have all that written down. Next, I would say that we have 2 solutions here. X is greater than or equal to -1, and x is less than 9. And so now I just got to put that on a number line and graph it. So for instance, here's -1, here's +9. Greater than -1 means to the right of -1, and less than 9 means to the left of 9. So it's that region right there. Oh, and I forgot to do the circles. Sorry. Open circle on 9, closed circle on -1. Now you'll notice that only the place where they overlap is going to be the solution here. In other words, where the red and the blue mix, it's between -1 and 9. So my answer is -1 comma 9. And -1 gets a square bracket, 9 gets the parenthesis because of the less than versus the greater than or equal to. Any questions on that one? Okay. So now for the rest of today, and honestly we're almost done the lesson already, this is a short one. For the rest of today we're going to be talking about how domain and range interact with each other. We have not talked about what range is, but I have a feeling you can guess it. Domain, like we said before, is all the possible x values. It's what we've been doing so far today. Now for range, it's all the possible y values of a function. Now here's the thing. X values was easy because you just had two things to look out for, square roots and 0 in the denominator. But range is much more difficult. As a matter of fact, even I, the great Dan the tutor, I don't have an easy way to solve for the range. But I can tell you this. Basically, what you need to do to find the range is you need to look at the graph of the function. That's the missing blank. You got to look at the graph of the function and answer the range that way. So with that, I'm going to show you how you can find the range. Number 1, find the domain and range of the functions in the graph. Write your answers in interval notation. We see we have a graph here. As a matter of fact, this is actually the graph y equals, looks like the slope is 2. You can count the slope, it's 2, so 2x. And the y-intercept is 1, 2, 3, 4. 2x plus 4. We already know that the domain, based on this function, is negative infinity to positive infinity, because there's no domain errors. And that's a poorly drawn D right there. Let me draw that better, because I'm saying domain. And I'm going to use this shorthand, D for domain, R for range. But even if you didn't know what the function was, you don't need it. You just look at this graph. You know the arrows mean it goes on forever. It's going on forever to the left and to the right. So that's why it's negative infinity to positive infinity. Now the easiest way, again, I can describe range is the low point to the high point. If I ask you what's the low point, it's not the lowest point on the graph, because remember, the arrow goes on forever. The lowest point is negative infinity. And similarly, the highest point is positive infinity. So in other words, my range is negative infinity, comma, positive infinity as well. So there's my domain, there's my range. Any questions on that first one? Okay. Number 2, I have a parabola shape. And I see that basically for domain, what x values do I have? Well, it's going to go forever to the left and forever to the right. In other words, it's going to go to negative infinity and positive infinity for the x. So that means negative infinity to positive infinity. Low point, high point. Now for the range, I got to think of my low point and my high point. Looks like the high point is infinity, again because of the arrows. And the low point is this point right here. That point is negative 2. So in other words, my low point's negative 2. My high point is infinity. And the negative 2 is going to get a square bracket because we are including negative 2. How do I know I'm including negative 2? It's because basically there's no open circle. Like, I'll admit I drew the dot there, but the only reason why it would not be a closed circle at negative 2 for the y direction is if the graph literally had an open circle in the graph. I don't think we're going to be seeing that today, although it's possible that in your math career in Algebra 2, your teacher does that to you. But since there's no open circles on the graph itself, you assume you include negative 2, it gets the square bracket. Long story short, when in doubt, put a square bracket. Include it. So there's our answer for number 2. Now for the next one, see if you can do number 3 by yourself. Pause the video, give it a try. Okay, I'm going to explain the solution now. So this one's a little bit trickier because you see you have, this low point right here and this high point right here. But remember, that's not the high and low point. Why not? Because the high and low point is for the whole graph. And again, you look at the arrows. It looks like for the x and the y, you're going to negative infinity and positive infinity. So for that reason, the domain is negative infinity to positive infinity, and the range is negative infinity to positive infinity. So in other words, you ignore the stuff that's going on in the middle. I only care about the highest point and the lowest point. And actually, one more thing I want to say about all of the functions we've looked at so far is that, let me just go back to the first one. This first one is called linear. It's in the y equals mx plus b family. That's linear. Linear, we say, is an odd function, or at least has an odd exponent, because x is to the first power odd number. Next we did a parabola, the y equals x squared family. That's what a parabola is. Anyways, you see that this is even because the squared is even. This last one we just looked at, this is y equals x cubed family. And when I say family, I mean like it's not y equals x cubed exactly, but it starts off with y equals x cubed, and that's an odd number, so that's why it was negative infinity to infinity. And for this next one, number 4, I'm just going to tell you this is a y equals x to the 4th family, which means it's even. And the difference between even functions and odd functions is that odd functions, in other words, number 1 and number 3, both of those are going to go from negative infinity to positive infinity almost automatically. And then whenever you have an even function, the domain is still negative infinity to positive infinity, because just look at the x values. The x values, you go all the way to the left, negative infinity, all the way to the right, positive infinity. But the range is not infinity to infinity. So what's the range here? Well, it looks like the highest point is 1, 2, 3. The highest point here and here is both 3. The lowest point is negative infinity. So it looks like the range should be 3, infinity. I'm sorry, negative infinity. And then parenthesis, square bracket. Can someone tell me what's wrong with my range? The problem is you need to go from low to high. I wrote it wrong on purpose, just to make you think. You need to write it negative infinity, 3. That has to be the order. And there's our answer for the last one. And just like that, that's going to conclude today's lesson. I know it was a short one, but I think there's a lot of good stuff in here. And remember, you got to practice this, because domain and range is something that you are, I almost guarantee you, going to forget at some point. And it is one of the more important topics in math, in my opinion. So thank you all for joining me. I'll see you next week. There's only 2 weeks left. Remember, we're ending on lesson 8. So this is 75% done now. Congratulations. So 2 more lessons to go. I'll see you next Wednesday. Take care, and bye-bye.